Alright, hey guys, welcome to our first past paper. We're doing January 2020 paper 1. We can see here that in a paper 1, we have 1 hour and a half to do 60 questions. Another thing about a paper 1 is that no calculators are allowed. So we will have to do all of the questions mentally, and so we'll take a look at some mental arithmetic stuff as well. And another thing is, when you shade your answer, you want to shade your answer completely. And what I would suggest is that you shade it lightly first until you are sure. Because if you are not sure and if you get the answer wrong, you need to be able to erase that without leaving a mark. So when you're shading your answer, shade it lightly, and then once you're sure that the answer is correct, or you're sure that that is the answer that you want to leave there, then you could shade it a little darker and try to be neat about it, right? So let's get started. And you can see here, if you want to change your answer, erase it completely. And there are other things here that I hope you can read. But calculators and mathematical tables are not allowed for this paper. And any working, I suggest that you do all of the working on the sheet. Don't do it on scrap paper, do it on this sheet so the examiners could actually see your working, right? So let's get started with the first few questions being number computation. What is 40%? What percentage of 40 is 8? Look at the wording. A lot of people will say, well, what is 40% of 8? So they'll do 40 over 100 multiplied by 8 to find 40% of 8. But that is not what they want to ask you here. And of course, 40% of 8. So be really careful as to how you word the questions, right? How you read the questions. What percentage of 40? Of 40. So 40, and they want to know what percentage of 40 will give you 8. So what percentage? What over 100 multiplied by 40 will give you 8? And of course, I like to use algebra for everything, right? Because algebra is just super crazy stuff. So x now over 100 is going to be equal to 8 over 4. So sorry, x over 10. So x over 10 is going to be equal to 2. Therefore, x is going to be equal to 20. So what percentage of 40 is 8? Well, it is 20%, right? And of course, you shade on your answer sheet. You do not shade on the question paper. You will be given an answer sheet in the exam that you will shade on. And this is equal to what? Well, we can see here it's to the power of minus 2 or negative 2, right? So we know that if you have anything to the power of a negative number, that is actually 1 all over a to the positive number. So what I could say is that this is actually 1 all over 2 on 3 squared. And now I could work out 2 on 3 squared. That is 1 all over. I could just work out 2 2s are 4 all over 3 squared is 9. And therefore, this actually works out to be 9 over 4 because it's the reciprocal, and this is D. We have here a series question. Now, generally, when it comes to these square roots, you could actually do a lot of stuff inside of a square root if it was dealing with multiplication or if it was dealing with division. But we're not dealing with multiplication or division, we're dealing with subtraction. And no, you cannot simply say that the square root sign negates these squares. No, it would have worked if it was one number. Yes, you can do that. But if it's two numbers, it's a little bit more complicated. So what we'll have to do is we'll have to see if we can minus these two numbers. Now, let's just say that you did make the mistake of saying that the square root sign cancels the square, and so you just end up getting 17 minus 15, which is 2. You can see that they actually have that 2 there. So they are encouraging you to make that mistake, but 2 would actually be the wrong answer. What we would need to do is we would need to find out what is 17 squared, and remember, we don't have a calculator. So what I would do is I would use my distributive law. I would say, well, 17 squared is actually what? 10 plus 7, which is 17, squared, which means that I'm multiplying 10 plus 7 by itself. And now I can use distributive law real quick. 10 times 10 is 100, plus 7 times 10 is 70, plus 10 times 7 is 70, plus 7 sevens are 49, and that will give me 100 plus 140 is 240, plus 49 is 289. So 17 squared is 289. 15 squared, I'm going to do the same thing. 15 squared is 10 plus 5 into 10 plus 5, and I could use the distributive law. 10 tens are 100, plus 50, plus another 50, plus 25, so that'll give me 225. And now I could say, well, okay, 17 squared minus 15 squared is really 289 minus 225. So of course the 200s are gone, and we really end up having 89 minus 25, which is 64. And so really and truly the question is asking us the square root of 64, which is 8. So 8 is the actual answer here. Now the square root of 191 lies between, for this question, we should want to use trial and error a little bit. So 191, well, we know that 12 12s are 144, right? So the square root of 191 is what? Well, 12 12s are 144, so 144 is definitely on this side. What about 13 by 13? Well, 13 by 13, I could do the same thing, 10 plus 3 into 10 plus 3, or I could just multiply it normal. I like to do it this way. 100 plus 30 plus another 30 plus 3 3s are 9, so that's 169. So we can see here that 191 is not between 144 and 169. So it's definitely not that, right? And we could also see here that it needs to be a larger number than 13. So maybe I'm guessing it's 13 and 14. And so we know that 13 is 169, which is less than 191. I wonder if 14 squared is 10 plus 4 into 10 plus 4, which is 100 plus 40 plus 40 plus 4 4s are 16, right? And that is 180 plus 10 is 90, 196. Well, look at that, 196 is definitely above 191. And so we could see here that the square root of 191 would actually lie between 13 and 14. In terms of this part 5 here, 99 times 101 has the same value as, and we could see here it's a bit of the distributive law. So 99 times 101 is just like what we were doing all of the time. We could say it's 99 times 101, right? If I split this 101 into 100 plus 1, that'll be 99 times 100 plus 99 times 1. 99 times 100 plus 99 times 1. So that will actually be D, 99 times 100 plus 99 times 1. There are 40 students in a class. Girls make up 60% of the class. 25% of the girls wear glasses. How many girls wear glasses? And a lot of these questions are actually repeat questions, and this is one question that comes in a lot, right? So 40 students are in a class, so we have a total of 40 students. 60% of the class is girls. Girls make up 60%. So let's find out how many girls are in the class. Right? 40 students in the class. 60% of 40 gives us 24. So we have 24 girls in the class. And out of 24 girls, 25% of those girls wear glasses. So 25% of the girls wear glasses. So that means that a quarter of 24 wear glasses. So that is 6. So therefore we have a 6 girls wearing glasses. For number 7, we could see here that we have n into a, which this is sets now. So we're dealing with set theory. So remember, this here stands for the cardinal number, the number of elements in A. And this is how we write the cardinal number of a set. So the number of elements in A is m. So we have a set A. And how many elements are there in the set A? Well, we have m. That is, this here is the number of elements in it, the cardinal number or the order. So then the number of subsets in A can be represented by, and we know that the number of subsets is simply 2 to the power of that order there, 2 to the number of elements. So we are talking about A, which is 2 to the m, and it is quite blurry there, so I apologize for that, but this is 2 to the m. And well, you can see that nothing else looks like 2 to the m. So just again, one more time, n into A, this stands for the cardinal number of the number of elements in the set A, and that is m. And if we want to know how many subsets are in the set A, that is actually 2 to the power of the number of elements that we have. Now, which of the following statements describes the set of integers greater than 3 but less than 6? So if we want numbers, right, that are greater than -3, less than 6, and it's an element of integers. They didn't say anything here about it including 3 and it including 6. They said greater than, less than. So these guys here that have the equal signs, I'm going to rule that out one time because they didn't say anything here about it including -3 and 6. The following statement describes the set of integers greater than -3, so it would have to be this, and less than 6. The answer is D. So for number 9, which of the following pairs of sets is an example of a disjoint set? And if you remember when we did sets, a disjoint set, if you have the universal set here, a disjoint set represents two sets that do not intersect at all. These two sets are totally separate from one another. So we could see here, if we look at it, multiples of 2 and multiples of 3, well, we have 6 being a multiple of 2 and 3, so that intersects, right? We have multiples of 5 and factors of 20, well, those intersect. Whole numbers and rational numbers, well, I could say that 2 over 1 is a rational number, and it's also a whole number, so that intersects. But even numbers and odd numbers does not intersect, so this here is the answer. Those sets are disjoint. Number 10, given the set 1, 3, 6, 8, 9, 12, 15, and B, which is 6, 9, 12, which of the following statements are true? Well, B is 6, 9, and 12. So we can see that B is a subset of A. So definitely this is true. And we could tell that all of the rest of them are not true. B is the complement of A and all of that. Nice, easy question, this one. Number 11, 30 students in Teacher May's class have either a dog or a cat, or none of the two, right? All of the students who have a cat also have a dog, right? So 30 students in Miss May's class either have a dog or a cat or none of the two. So if I have all of the students in Miss May's class, right, they could either have a dog or they can have a cat or they can have none of the two. So if they don't have the two, then they'll be outside here in the universal set. All right. And they didn't say anything about them intersecting. They didn't say anything about having a dog and a cat, right? They say they could either have a dog or a cat, right? Or none of the two. All of the students who have a cat also have a dog. Interesting. All of the students who have a cat also have a dog. So that means that all of the students who have a cat also have a dog. So pretty much these two sets are the same. Yeah. If the number of students that have cats is 12. Oh, I see it now. So, and the number of students that have dogs are 16. Well, the number of students who have dogs that's the bigger set that have 16 in it. And they say that all of the students who have cats, who have a cat, also have a dog, which means that the number of students who have cats, 12, all of them will have a dog. So we could see here that these are the number of students who have cats, which are 12 students, and these are the number of students who have dogs, which are 16 in all, including the 12. Which of the following represents? You see, I didn't even look at it yet, but I could see here that this last one is definitely the one that I'm looking for, where 12, you'll have out here 4, and you'll have the rest of the students who don't have anything there. So this was a little bit tricky, and what made it tricky was the language. So you have to read it really, really carefully. Let's look at number 12, and we're dealing with more set theory. In which of the following Venn diagrams is the region A intersect B complement shaded? Well, we could see, what do we want? We want A intersect B complement. So what do we want? We want all of the things that are in A, but we want nothing that is in B. Nothing that is in B, including whatever might be intersecting with A. I don't want anything that is in B at all. So that gives me this one here, because we could see for part A, we have all that's in A and we have all that's in B. So this is A union B, actually, is what this is, right? We can see for part C here, we have A, and this is just simply the set A alone. Over here, we have, we could call it A complement, right? Which is everything that is not in A, so it's only those things in B. And over here, well, actually, no, this is A complement intersect B is what this is. So we have all of the things that are in B and nothing that's in A. But we're looking for A, everything that's in A, but nothing that's in B. So this will actually be the set that we're looking for. Number 13, and we're talking about consumer arithmetic for these next few questions here. If Eastern Caribbean is $2.50 equivalent to US $1, then 20 EC is what in US So we could see here that we could say that 2.5 EC is equal to 1 US. Therefore, 1 EC is 1 all over 2.5, and 20 EC is 1 all over 2.5 multiplied by 20. Right? So 1 all over 2.5, this is 2.5. Remember, 2.5 is 2.5. And 2.5 is 2 2s are 4, and 1 is 5. 5 on 2. Right? And what do I have here? I have 1 over 5 on 2, which is really 2 on 5. So 1 over 5 on 2, this is 2/5 of 20. So 4, 5 4s are 20, 4 2s are 8. So that will be 8 US dollars B. We have here question number 14, the simple interest on $600 for T years at 5%. You know, I mean, at the end of the day, all I'm going to remember is simple interest is equal to principal by rate by time all over 100. And then they say the simple interest on $600. So $600 is the principal times 5% per annum, that is the rate, times T years, that is the time T, all over 100. And that simple interest is 120. So they can see here that, we can see here that if we look at the English, and English is really the biggest problem in maths, the simple interest is 120. Alright, so be careful with that. So the simple interest is 120. The value of the T or time, so we're basically doing a subject of the formula here. So I'll have to take this 100 and put it over here. So I'll get 120 multiplied by 100, and it'll be divided by 600 times 5. And that is what will give me T. And we can see here that that is A. Given that Y varies directly as X, and Y is equal to 19 when X is equal to 152. So given that Y varies directly, variation and proportion, we're dealing with a little bit of algebra now. So Y varies directly. So that means that Y is directly proportional to X. Right? And that way we could have this equation Y is equal to Kx, where K is the constant of proportionality. Right? So which of the following equations represents the relationship between X and Y? Well, I could see here that they tell me that when Y is 19, X is 152, and so that I could work out K is equal to the 19, and I throw in across the 152 divided by 152. And I could definitely see here that this is going to work out to be some sort of a fraction, 1 over something, right? So let's check and see here what's going on. So immediately now, because I'm seeing this, I could rule out this. Right? And 1 over 133 doesn't really seem to be that. So maybe it's 1 over 8. So let's just take, if this is 1 over 8, let's just take 8 and multiply it by 19 and see if I get 152. Well, 8 times 10 is 80, plus 8, 9 8's 56. No, 9 times 8. 9 8's are 70, right? 80. And 9 8's are 72. So we can see here that 8 and 8 is 16. So 8 and 7 is 15. 152, right? So therefore, just kind of by trial and error, I could see here that this is end up going to be 1 over 8. A man's salary is $45,000. His tax-free allowances total 13,000. So his salary is 45,000, and out of the 45,000, 13,000 cannot be taxed. Right? So if 13,000 cannot be taxed, because that is his tax-free allowance, is 13,000. So 13,000 cannot be taxed. So therefore, 5 minus 3 is 2. 32,000 can be taxed. He has to pay tax of 20% on his taxable income. So the tax payable, or the amount of tax he pays, will be 20% of 32,000, which will be 20 multiplied by, so we can see these two zeros here. So 2 times 3, 2 3s is 6. So that will give me 60, plus 2 2s are 4. So that is $6,400 is his taxable income. 17. A man pays 60 cents for every 200 meter cube of gas used, plus a fixed charge of $13.75. So he pays $13.75 plus 60 cents for every 200 square meters. So how much square meters does he use? Right? So he uses 55,000 meter cube of gas. So 55,000 meter cubes of gas. So 55,000 divided by 200. Zoop, zoop. So 2 divided by 5,500. 500 divided by 2 is 250. And then 50 divided by 2 is 25. So this here is going to end up being 275 meters cubed. So it's 275 that he has to multiply by 60. So 275 meter cubed multiplied by 0.60. And how could we do this mentally? Well, we could just kind of multiply it by 6, yeah? So we could go, so if we just pretend, let's just pretend and multiply it by 6, right? So if we multiply it by 6, 275 times 6. So if we take that 6 times 200, so 6 2s are 1,200, plus 6 times 70, so 7 6s are 42, and the extra 0 for the 70, and then 6 5s are 30. Alright, so that will mean I have 0, I have 5, 4, 4, 5, 6, right? Now 1650, that's when we multiply it by 6. But we're going to take the point and put it over here. So therefore we'll take this point and also put it over here. So we get the answer being $165 is what he actually pays. A car presently valued at $12,000 depreciates at a rate of 10% per annum. So a car presently valued at $12,000 depreciates at a rate of 10% per annum. What will be the value of the car after 1 year later? So after 1 year, it's going to depreciate by 10%, right? So 10% of 12,000 is 1,200. Right? And so therefore it depreciates by 1,200. So 12,000 minus 1,200, 0, 0, 10 minus 2 is 8. And I'll now have 11 minus 1 is 10. And now I'll end up get 1080. So 10,800, right? 10,800 is the answer. Number 19. A dinner at a restaurant was advertised at $60 plus 18% tax. The total bill for this dinner would be, so I'd have to find 18% of $60. So 6 times 10 is 60 plus 6 8s are 48. And that'll be divided by 10. So that gives me $108 divided by 10, which is $10.80. That is the amount of tax, and so the actual dinner is going to cost $60 plus $10.80, which gives us $70.80, which is B. Number 20, a store offers a discount of 10% to customers who spend more than $20. Right? A store offers a discount of 10% to customers who spend more than $20. If a customer's total bill is $80, what will he actually pay? So if he pays $80, right, obviously it's more than $20, so he will get the 10% discount. So the 10% of 80 is $8, and so he will get an $8 discount, which means he will get a discount of $80 minus 8, which is $72. So we have the answer here being C. And question 21, we are getting into some algebra here, algebra being my personal favorite topic. And we can see here that we have a fractions question. And as I always say, for an algebra fractions question, you just treat it like a normal fraction, right? We can see here that these fractions have the same denominator. So if they have the same denominator, you keep the denominator. Yeah, you do not multiply, right? So if you have, for example, 2 on 5 plus 1 on 5, you just add your numerators, 3 on 5. And you notice we don't do anything with the denominators. So it's going to be over 5. And 4 plus 2 is 6. So the answer is 6 over 5x. We have here an operations question. M operation n, and we did do this in class, is equal to the square root of m cubed, and it's quite hard to read, minus n cubed. Then 5 operation 2 is going to be what? So what we say in here is m is actually 5, and the operation, and n is actually 2. So this is m, and this is n. So 5 operation 2 is going to be the square root of m, which is 5 cubed, minus n, which is 2 squared. And that is going to be the square root of 5 cubed. Well, 5 5s are 25, and 25 by 5 is 125, if I did that correctly. Yeah, minus 4, 2 2s are 4, so that'll give me the square root of 125 minus 4 is 121, and I believe that the square root of 121 is indeed 11. 22. Given that this entire equation here is equal to 7, the value of x is, so this is a solve for x question, and so what we have to do is we have to use distributive law and expand this entire thing and then simplify and find for x. So 3 into x minus 1 minus 2 into x minus 1 is equal to 7. Let's expand this side. So that's 3 times x is 3x. 3 times minus 1 is minus 3. Then I have negative 2 times x is negative 2x. And then negative 2 times negative 1 is plus 1. And that is equal to 7. So 3 minus 2 is x. And then I will have negative 3 plus 1 is negative 2. That is equal to 7. So therefore x is equal to 7 plus 2. X is equal to 9, which is D. We have another simple question here. And this one is basically testing your knowledge of brackets. Negative minus 2q minus 3q is equal to what? Well, this negative is negative 1 multiplied by that. So that gives us positive 2q minus 3q, which is actually just negative 1q, which is negative q, which is C. Right? Now you notice we hardly, apart from these two questions, hardly have any C's. So, when in doubt, choose C is not a reliable thing. Yeah. If x is equal to 2 and y is equal to 4, then the value of this equation is, well, we know x is equal to 2, and I do believe that is x squared, eh? So x is equal to 4, so that's 4 squared plus 3, y is equal to 2, all over x is equal to 4 and y is equal to 2. So that will give me 4 4s are 16 plus 3 2s are 6 all over 4 2s are 8. So 16 and 4 is 20 and 2 is 22 all over 8. So as a mixed number, that is 1 8 is 8, 8 2s are 16, 8 3s are 24. So 8 2s are 16 and 6 all over 8. And that it could further be reduced to 2, and this fraction could actually be reduced to 3 2s are 6, 4 2s are 8, 2 and 3 over 4, which is D. For P here, we have if P over 5 is equal to 20, then P is equal to what? So if P over 5 is equal to 20, then P is equal to 20 multiplied by 5, which is D. So we see here we sort of have a vector kind of thing going on here for question 27. Refers to the following vectors P and Q. So P and Q is that the vector P minus Q is represented by, so if we go P 3 7 minus Q, which is negative 2 5. Right? What do we actually have here? 3 minus minus 2. And then 7 minus 5. So that gives us 3 and 2 is 5. 7 minus 5 is 2. So that's positive 5, positive 2. And that gives us C. So you can see with vectors, we just the top value and the bottom value, we just subtract those. 28 is based on this, so we see that we reach the vectors part here, and the vectors part of our questions. So the diagram, refers to the following diagram. Item 20 refers to the following diagram of a parallelogram in which EF is parallel to HG. Thank you for telling me that. And EH is parallel to FG, so all of these sides, they are parallel, right? EF is equal to K and EH is equal to M. We are seeing that. Express EG. So EG is this, right? And notice the direction EG, so from E to G goes in that direction. And we're talking about the parallelogram law. So the parallelogram law will basically say, well, hey, since this here is equal to this because it's a parallelogram, means that I can actually call this K. And that means that in order to get from E to G, I can actually go this way plus this way, which is the triangle law. So we can actually see that that is M plus K, which is the same as K plus M because it's commutative. Addition is commutative. And we can see here that A is the correct answer for that. Question 29. If 5 times that vector is equal to 4 times 10, 20, then the values of x and y are what? And this is a really interesting question. So we could just see that 5, let's deal with the x's first. 5 times x is equal to 4 times 10. Therefore, 5x is equal to 40, and x is equal to 40 divided by 5, which is 8. And now we can go 5 times y is equal to 40, sorry, not 40, but 4 times 20. So therefore y is going to be equal to 4 2s are 8, that is 80 divided by 5, which is 16. So we can see here that x is 8, y is 16. So for question number 30, we are starting to get into matrices now, and we're seeing here that item 30 represents the following matrices A and B. What is the product? So obviously, in order to multiply these matrices, well, this is 2 by 3, right? 2 rows by 3 columns. This here is 3 rows by 2 columns. So yes, they can be multiplied, and we can expect to have a 2 by 2 matrix. We could see here that all of these guys are 2 by 2 matrices, so it doesn't really help us that much. Otherwise, we could have narrowed down the answer, but no, we actually have to do the multiplication. So let's get into it. 1, 3, negative 3, 3, 0, 5 is being multiplied by 3, 2, 0, 0, 1, 5. So what I'm going to do is I'm going to take this first row and multiply it by the first column. So what will I get? 1 times 3. 1 times 3 is 3 plus 3 times 2. 3 2s are 6 plus negative 3 times 0 is 0. Right? And now I'll take this first column and multiply it by the second, sorry, the first row, multiply it by the second column. So 1 times 0 is 0. Plus 3 times 1 is 3, and negative 3 times 5 is minus 15. And I'll just do the same thing here with the underneath. 3 3s are 9. 0 times 2 is 0, and 5 times 0 is 0. Alright, so now by this next column, 3 times 0 is 0, plus 0 times 1 is 0, plus 5 5s are 25. So I could see here that this will end up being 6, 7, 8, 9, and this is 9 under here. And over here I have 3 minus 15, which is negative 12, and this is 25. So I could see here 9, 9, negative 12, 25, that is definitely E. Right, so let's look at question 31. The volume of a cube whose edge is 6 centimeters long is. right? So we know a cube and 6 by 6 by 6. So we have the height times the base times the length. So it's really 6 cubed. So 6 6s are 36, and 36 times 6. 6 3s are 18, 19, 20, 21, 260. Now, if it took a speedboat 9 hours to travel a distance of that, what was the average speed? Right? So remember that speed is the distance moved all over the time taken. So that would be 1080 divided by 9. So that would probably work out to be 102. So 1080 divided by 9 will work out to be 120. So how do I do that? Is, well, I know that 18 into 9 is 2. So I'm looking for an answer with 1 and 2 in it. Yeah, and well, all of the answers have 1 and 2 in it. So so then I'll try. Kitties, what are you all doing here? So I'm pretty much sure that it probably will not be 1200, and it probably wouldn't be 12. So I could actually just try these two in terms of 120 times 9. 0, 9 2s are 18. 9 and 1 is 10. And yes, so it is 120. Number 33, 2500 milliliters expressed in meters is what? So I know that I have 10 millimeters is 1 centimeter. And 100 centimeters is 1 meter. Right? So therefore, is 1 centimeter. So 1 centimeter is 10 millimeters, right? And 100 centimeters equals 1 meter. So therefore, I have 100 times 10, which is 1000 millimeters, gives me 1 meter. So therefore, 1 millimeter is 1 over 1000 meters, and 2500 millimeters is 1 over 1000 multiplied by 2500, zoop, zoop, which is 2.5. 25 divided by 10, so that is 2.5 meters. An aircraft leaves A at 1600 hours. 1600 hours is 4 o'clock, 4 p.m. Right? And arrives at B at 1930 hours. So 1600 hours, 1930 hours. So how many hours is that? That is 16, 17, 18, 19. So that's 3.5 hours. Traveling at an average speed, so 3.5 hours at an average speed of 550 kilometers per hour, right? A and B are in the same time zone. The distance from A to B in kilometers is what? So we know that speed is equal to distance over time. So therefore, distance is going to be speed times the time, which means that if I have 550 kilometers per 1 hour, then in 3 hours I'll have 550 times 3, and in 3.5 hours I'll have 550 times 3.5, right? So it'll be 550 multiplied by 3.5. And I could also say that that's 550 multiplied by 3 plus a half. So I could take the 550 times 3 first. 550 times 3. 0, 5 3s are 15, 5 3s are 15, and 1 is 16. 1650. And then 550 plus a half, well, times a half is, well, a half of 500 is 250. And then a half of 50 is 25. So that will be 275. And so 1650 plus 275 should work out to be around 1925 kilometers, which is D. So a rectangular plot, so I know it's a rectangle and it's 15 meters long and 12 meters wide, right? An area of 80 meters is used. So 80 meters is going to be used here. Meters squared is used for a vegetable garden, right? What area is not used for the vegetable garden? Well, I need to find the area of the full plot. So 15 multiplied by 12. And I have many ways that you could do this mentally. 15 times 12, well, I could say that this is 15 times 10 plus 2. So 15 times 10 is 150 plus 15 times 2 is 30. So that gives me 180. So the full area of this is 180 meters squared. And 80 meters squared is used for a vegetable garden. So 100 meters squared is not used for the vegetable garden. The distance around a lake is 8 kilometers on a map. The distance around a lake is represented by 2 centimeters. The scale of the map is what? So the distance around a lake is 8 kilometers, and this is represented by 2 centimeters. So 8 kilometers is 2 centimeters. So I can say 2 centimeters is 8 kilometers. So therefore 1 centimeter will be 8 divided by 2, which is 4. So the distance around a lake is 8 kilometers on a map. This distance around the lake is represented by 2 centimeters. So 2 centimeters equals 8 kilometers. So therefore 1 centimeter would represent 8 divided by 2, which is 4 kilometers. So in terms of a ratio, I'd want them to be to have the same unit, yeah? So how much centimeters is 4 kilometers? Well, remember that 1 centimeter is actually, sorry, not 1 centimeter, but 100 centimeters gives me 1 meter. And so 1 meter is 100 centimeters. So 1,000 meters, which is really 100 centimeters, right, is 1 kilometer. So therefore that gives me 100,000 centimeters is 1 kilometer. So 1 centimeter to 400,000 centimeters is basically the ratio that we're dealing with here. So number 37 refers to the following diagram not drawn to scale, which shows a cuboid, right? So the cuboid, the volume of the cuboid is 320 centimeters cubed, and the height of the cuboid is 5. If the cuboid has a square base, then what is the length of one side of the cuboid? So the cuboid has a square base. So we say that this is a square. So if this is x, then this will be x. The volume of a cube is the length times the breadth times the height. So that gives me x times x is x squared. So 5x squared is equal to 320. X squared is going to be equal to 320 divided by 5. So x squared is going to be 5 into 32. That is going to be about 64. And therefore, x is going to be the square root of 64, which is 8. So we have 8 centimeters here. A square has the same area as a rectangle, right? So the area of this square is the same as the area of this rectangle, okay? With sides 9 and 16. So 9 here, 16 here, right? What is the length of the side of the square? Well, let's find the area of the rectangle. So the area of the rectangle is 16 times 9, which is 9 multiplied by 10 plus 6, right? Which is a 90 plus 6 times 9 is 54, right? So that is 144. So therefore the area of the square is 144 as well, because we are told that both areas are the same. So therefore, one length of the side of the square will be the square root of 144, which is 12 centimeters. So 39, we're dealing with some statistics now. The median of the numbers. So remember what median is. The median is really, so we have the mean, which is the average, the mode, which is the most popular to occur, and the median, which is the one that is smack in the middle. And all of the numbers are already in numerical order. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know with an even number, we have to take the two middle numbers here. So that's 6 and 7. So 6 plus 7 is 13 divided by 2, which gives us 6.5. So 6.5 is the median here. So number 40 refers to the following frequency table, which shows the time taken by 20 students to solve a math problem. Right? So we have here 5 students take under 2 minutes, 9 students will take 3 to 5 minutes, 2 students will take 6 to 8 minutes, 4 students will take 9 to 11 minutes. The lower class boundary of the interval 3 to 5 is, well, the lower class boundary of the interval 3 to 5 will actually be 2.5. And remember, the lower class boundary of 3 to 5 is actually 0.5 below this one, right? Below the lower limit or the lower boundary there. Question 41 refers to the following table, which shows the frequency of scores obtained by students in a test. So I see the scores here. So 8 students got a score of 2, 12 students got a score of 8, 2 students got a score of 11. The modal score is what? So the modal score, remember the mode is the one that is the most popular, right? The mode is the one that's the most popular. So we can see here the most popular is this one, 12 students, right? So 12 students got a value of 8. So 8 is the score, right? Not 12, they asked for the modal score, right? So the modal score is the score that most amount of students got. And 12 students got that score of 8. So don't make the mistake of putting 12, right? Question 42 refers to this huge table here. It's a cumulative frequency curve which shows the mark obtained by 200 students in a test. So we can see the marks obtained by 200 students in a test. So we could see, for example, that 20 students got 20 marks or less. We could see here that 80 students got 35 marks or less, and so on. So the median of the marks scored by 200 students is what? Well, the median will be in the middle. So when we're talking about 200 students, we'll be talking about the median here, which will be about 100. And that 100 will come across here and cut down here. So that will give us a score of, let's say, 35. And let's see if they have anything between 35 and 40. Yes, they do. They have 37.5, which definitely looks like our mark. Number 43. How many, so it refers to this bar chart here, and the bar chart refers to the number of children in a survey and how old they are. How many children took part in the survey? Well, we could see here that we have 3 students over here, plus 4 students over here, plus 2 students over here, plus 5 students over here, plus 1 student over here. So that'll be 3 plus 4 plus 2 plus 5 plus 1. Which gives us 15 students in all. 600 students write an exam. The probability of a randomly selected student failing the exam is 1/5. How many students are expected to pass? Well, if 1 in 5 students are expected to fail, that implies that 4 in 5 students are expected to pass. And what do we have here? 600 students write an exam. So therefore, 4 out of 5 of 600 is expected to pass. So So 5 12s are 60, and 120 times 4, well, 12 4s are 48, so that's 480 students are expected to pass. Number 45, here we're getting into functions. So item number 45 refers to the following diagram. So we could see here a very arrow looking like diagram, and the relationship best describes the mapping 1-to-1. Is it 1-to-1? Well, no, it's not just 1-to-1, because I have this one going to this one, but I also have this one going to this one. So to me, this looks like many going to one. So we have here many to one. It's not many to many, and it's not one to many. Alright? So just as a recap, this would be one to many. This would be 1-to-1. This here would be many to many if I had here, and then if I had here like that. That would be many to many. And this, of course, will be many to one, which is pretty much what we have here. 46 refers to the following arrow diagram. So more arrow diagrams here. The arrow diagram above best describes the relation. So we can see here that x is 2, y when y is 8 and 10, and x is 4. So when y is 8, so let's just see. So what are we going to end up with? Y is less than x. So we could obviously see here that that is not true. When y is 8, x is 2. When y is 8, x could also be 4. So y is definitely more than x. y is a factor of x. Well, no, that would mean that y is less than x, because remember, the factors are less, the multiples are more. X is a multiple of y. Well, the multiples are bigger. So we can see here all of the x's are smaller, but x is definitely a factor of y. So we can see that here 2 is a factor of 10 and 8. Yes. 2 and 4 are factors of 8. 3 is a factor of 9. So 46. 47. Which of the following line graphs represents this? So we could see here which of the following line graphs represent x is less than -2, sorry, it's greater than -2, but it's less than or equal to 4. So that means that less than or equal to means that it should be shaded by the 4. None of them are shaded by the 4. So I figure this here might be some sort of an error. Right? Really and truly, what I'm supposed to have is -2 unshaded up to 4 being shaded. I'm not seeing any of the 4s shaded here. I'm not seeing any of the -2s shaded here. In fact, all of them look the same. So it could be that this is an error. Don't they all look the same? Yeah, they all look the same. So I mean, guys, I think that this is an error on the path of CSEC. You know, they are not seeing any difference here. They probably would recognize that it's an error and they wouldn't mark it for that. Right? 48 to 49 refer to the following graph of a quadratic function. My God, we can hardly see what's going on here. I really hope that CSEC decides to use a lighter graph paper next time. But we could see here that this is the function y is equal to 4x minus x squared. We could see that x squared is a negative, so that implies a maximum. Remember, if x squared was positive, it would be a minimum. So the maximum point is, and what we could see here, the maximum point is about here, which is 2 on the x, 4 on the y. So C is the answer here. 2 on the x, 4 on the y, C. 49. The values of x at the point where intersects the y is equal to 0 are. Y is equal to 0. Please remember that is the x-axis. The x-axis is y is equal to 0. We could see here, well, we could barely see here, that it cuts this x-axis here at 0 and here at 4. So we could see here that x is 0, x is 4 is a. Which of the following represents the equation of a straight line? Remember, the equation of a straight line, x must have a power of 1 for it to be linear. You can't have any other powers here. In this case, this is the answer. X over here has a power of 2, so it can't be any of those. But in this one as well, even though it looks like x has a power of 1, it does not, because it's a denominator. And if we remember our laws of indices, this is actually 4x to the power of -1. So this here is not the answer. The answer is B. Which of the following sets is represented by the function f of x is x squared plus 3, where x is an element of the set 0, 1, 2, 3. So x squared plus 3, and they say x is an element of 0, 1, 2, 3. So therefore, we could say y is equal to that. So when x is 0, right, y is going to be 3. All right, so we see, so the first point is 0, 3. Right? When x is 1, 1 squared is 1 plus 3 is 4. So we see here the next point is 1, 4. Right? And look, 0, 3, 1, 4, we have two options. We have this and we have this, 0, 3 and 1, 4. Right? So when x is 2, 2 squared, 2 2s are 4. 4, 5, 6, 7, y will be 7. So the next point is 2, 7. So we could see here that D will end up be our answer. Because D has 2, 7. And we could just make sure 3 3s are 9, 10, 11, 12. So 3, 12, absolute. A line L is parallel to the line of this. What is the gradient of the line L? Well, this is a really, it's actually quite an easy question, but it requires you to really know your work. The first thing that we have to do is we have to remember that a line, when it is in the form y is equal to mx plus c, m is the gradient. So the first thing that we have to do is take this line L. No, this is not the line L. This is just a line. The line L is parallel to this. So we have to take this and put it in the form. So we have 2x minus 5y minus 8 is equal to 0. I'll throw the 8 and the 2x there. So negative 5y is equal to negative 2x plus 8. And then y will be negative 2 divided by negative 5. So that is a positive 2 on 5x. And that will be minus 8 on 5 because the negative 5 will make this a negative here. So we see here that this line actually has a positive gradient, which goes like that. 2, 5, and it's a positive gradient. So the line L is parallel to this line. So a parallel line will have the same gradient. So that is 2/5. And just remember, if they had asked for the perpendicular line, a perpendicular line meant that 2/5 multiplied by the gradient of the perpendicular line would have given me negative 1. Yeah, so just remember these little things in coordinate geometry. Yeah. Item 53 refers to the following diagram, which shows a translation. All right. So we have A to B, and we have A prime to B prime. In the diagram, the translation, by which AB is mapped onto A prime, B prime, is represented by what? So we could see here that A to B, well, to get from 2 to 5, I'll have to go 3 horizontally. And to get from 5 to 7, I'll have to go 2 vertically. And we could see here that this here is the same. 3 horizontally. To get from the 4 to the 7 is 3 horizontally. And to get from 6 to 8 is 2 vertically. So we're dealing with a translation of 3, 2. Item 54 here, we have in the diagram PQ and RS are parallel, right? Which of the following best describes the relationship? Well, these are alternate angles, and alternate angles are equal. So yes, P is equal to Q. They're not collinear at all. Right? So it sails 8 kilometers due east from A to B. So this is A, and this is east. So this is B here, and this is by 8. And then it sails north from B to C, which is 6 kilometers. Right? So which of the following best describes the path of the ship? Well, A to B, this should be 8 and this should be 6 really. So this is no, because this should be 8 in this direction, and then here, yes, 8, 6, C. Right? So we can see that there. 56. Which of the following in each of the following diagrams, OA prime is the image of OA. So I see an OA. In each of the following diagrams, OA prime, the image of OA, which of the diagrams shows the reflection in the y-axis? The y-axis obviously will be here. If the y-axis is the middle line, this will be a reflection in the y-axis. 57. In triangle ABC, the angle A is x degrees and the angle B is 2x degrees. What's the size of the angle C? So if I have ABC, this is x degrees, this is 2x degrees. So I know that the angles inside of here is 180. The angles in a triangle is 180 degrees. Yeah. So C will be 180 minus x plus 2x, which is 180 minus 3x, which is D. 58 refers to the following diagram, which shows an enlargement. In the diagram, ABC is mapped onto A prime, B prime, C prime, where O is the center of the enlargement. What is the scale factor of the enlargement? So, well, we could see here, this is quite easy. This length here is 2. This length here is 4. So this 2 multiplied by 2 is 4. The scale factor is actually positive 2. Question 59 refers to the following pair of similar triangles. Yes. The length of MO. Where's MO? Or MO here. In centimeters is what? So if this is 3, remember similar triangles is basically the same principle as an enlargement. So in order to go from 6 to 3, I'd have to divide by 2. 6 divided by 2 is 3. So therefore 7 divided by 2 will give me 3.5 here. Nice and easy. And then the last question, this is a trigonometry question here. Now, which of the following refers to the following right angle triangle? Question 60. Yeah. And which trigonometric ratio is equal to 4/8? Right? Well, it depends on what you want to talk about. If you're talking about from the x angle or from the y angle. If you're talking about from the x angle, and let's just write our SOHCAHTOA one time. SOHCAHTOA. Right? So we could just have that there. And we could see here that from the x angle, we're dealing with the opposite and the hypotenuse. So that works out to be that sine of x. Yes. So we have the sine of x there. And we see here that it's equal to 4/8. 4/8 is the opposite over the hypotenuse. So yes, that will be the sine of x. Right. So that is it for this January 2021, was it? Right? A multiple choice 60 questions. I hope that it was okay for you. We did see one question that had an error, so I don't know how CSEC will handle that. But essentially, if you guys have any questions about anything in this paper at all, this was January 2020, so you can feel free to call, WhatsApp, or you can ask me in class, and I'll see you guys in class to correct the paper too.